Hi everyone. So now we're finally at the last lecture of this makemore, and now we're going to build a more complex architecture, network architecture, just like this. But we're not going to use this convolution layer yet. We just need to build a tree-like structure. Okay. So here, like the previous thing is still the same, but here you can see that we increase the block size because in previous we think that we almost we reached the limit of our model. And maybe and the reason the bottleneck may be because it cannot see the other characters previous more previous and a limited performance. So now we're going to make what it can see more previous characters more. Yeah. So now you can see that we have the block size of 8, and for each character you can see the previous 8 characters of it. Okay. So the basic linear network architecture is the same, and we added embedding here and the flatten and sequential, and we will talk about them later. Okay, so here's our final model. So what this embedding is that the embedding here is for the where we have the original code here. Like this C, we use this C to change our batch to the embedding, and then we concatenate, squeeze the vectors to one dimension to make the X input. But here that we just use this embedding and flatten to achieve that. So what we have done here in the embedding here, because we initialize embedding, we just use this normal render number normal weight here. And when we call, we just pass the input to our weight to get our embedding. And for the flatten here, you can see that here you can find this a little bit complicated, but basically what we do is if the input n, we just want it to flatten by the n. So for example, if the input here is 2, which means that we are doing this 2 combining to 1 here. So this is basically what we do here. And for this squeeze is we don't want to let our final, when we reach to the final layer, we want it to be two-dimensional, not three. So we use this squeeze here. Okay. And other thing is still all the same here. Yeah, so we trend and we try to plot our loss I, and we use this view here to make our plot more easy to see. Okay. So here some modification of the code and the results. So for example, we can see that original we have the 3 character context and 12K params, and we added to 3 to 8, and we also add this change wave. Okay, I'm not actually sure what happened here, but I believe that we change the, yeah, I guess I just cannot remember. So maybe, oh yeah, so here's that we use the wavenet. Okay, so this one is we only change the context from 3 to 8, and this is we change to the wavenet structure. And also we have a bug in batch norm before. It's because that there's batch norm here. When we do this mean, originally we only do the mean by the 0 dimension, so which means that because it should uh only you should mean the all of the dimension but the last one, and that is what a batch really inputs. So yeah, so after we change that, it could be a little bit uh better here, here a little bit. And for this one is that we increase the model size. Yep. So basically, this last step doesn't mention a lot of things, but I think that is still it makes our NN architecture more like PyTorch. For example, we add this sequential here, and you can see that you can put all of your layers in it, and just like the PyTorch NN dot sequential used. And yeah, so I believe that through all of this video, you will know the basics about how the how the PyTorch networks works in the internally. So after this lecture, we're going to use all of the PyTorch to build our neural network. Yep. And there are some other next steps. Yeah, so you can implement convolution network, convolute, and maybe add to know what's residual connection, speed convention, and set out the experimental hardness, because here for this block size, we'll just randomly try and run to check the result. Maybe you need better way to find the hardness. And also we're going to into the RN and STM over transformers. Yep. And I think that's all for this lecture. There's not that much to mention, but I hope that you finish all the lecture and you really learned a lot.